Hello, I'm Simon Watson, Field Applications Engineer for VectorCast. Today, we revisit a previous topic, faster unit test case execution on our embedded target or simulator, and a reduced requirement to flash the test harness. In a typical embedded target VectorCast configuration such as this one, we compile and link the test case input data, and then launch the debugger or simulator, or perhaps the flashing tool and COM port listener, and then wait for the execution to be complete. If we run a second test case, we do it all again. If we're concerned about the time to start the debugger and connect to the target, then we should ask if we can keep it running as a listening server and then connect to it on a test case by test case basis. We lose the atomicity of the traditional test case execution, but there are user exits to help manage this. Previously, we showed a debug server implemented as a loop in Texas Instruments Code Composer JavaScript. And today, we will look at the same idea with Keil's Microvision TCP socket server and compare that with a J-Link GDB client server setup. We'll use a little ARM board and see how much faster we can go. We can pre-start the Keil debugger as a TCP socket listener, and it opens the project that defines the USB connection to the target. If we're concerned about using a large number of slow flash cycles, then we should look at the Tools Options Target tab, where we find options to put the test case input into a data file or files. Some debuggers provide semi-hosting support for the test harness to read and write such files directly, but much more likely we'll use the debugger to upload the data. On a rare occasion when there's been a flashing tool but no debugger available, we have used a UART to upload the test case input. Our debugger socket client will be started when we execute our first test case, and it will flash the board to a known state. So this test case will take as long to run as with the traditional configuration. But now, in between test cases, the client remains connected and also remains in the Microvision debug session. So when this test case is ready to be run, after checking that the ELF file is unchanged from the previous execution, we need only to reset and run. If the ELF file has changed, we need to reload it or reflash it. So we need to drop out of the old debug session and then start a new session. There's no need to have visible command shells with scrolling output. That's just convenient if we want to see what's happening, and it makes for a more visual demo. What speed improvement do we achieve? Here we have 16 test cases executed in 12 seconds in the simulator, or 30 seconds in the target. The conventional configuration, where we load or flash every time, takes 85 seconds to execute the same test cases in the simulator, or 150 in the target. The same board can be managed by a J-Link GDB server. Here the GDB server is able to decide for itself whether we need to flash the board, and the GDB client and server setup is sufficiently fast that we don't lose much time by starting and stopping them for each test case, so we can retain our atomicity of test case execution and achieve a comparable speed. Could we do better? Yes. For example, there's potential for reducing the volume of output by replacing the output line 12-character file identifier by a 1-digit number. This will reduce the number of times we fill the output buffer, and hence the number of times the CPU needs to enter debug state. But we have reached a point of diminishing returns, and the 80-20 rule applies, and our factor of 5 times improvement is enough for today. Thank you for your attention.